Right. So good morning, guys. And now yesterday we started analytical functions. Okay. Right. So he was not started. Okay. Right. So analytical functions. Okay. The three types we discuss here. And now the syntax of analytical functions. Again, started any one day, continuously 1 week holiday I will take. Continuously. I will inform to you and taking 1 week leave. Then what happened? That 1 week, 10 days extension of your next level. Like I will take holidays. Then you understand how many months it will go, your course. Regularly we are coming to finishing our batch fastly. Just only 1 or 2 days only remembering that words. After 2 days is over, again started our own positions will come to us. Okay. Right. So here three functions here, and this is our syntax how to use analytical function name, over class, and partition by class name. And this partition by class name, what we said, guys, it's a optional part, and later order by column name, ascending or descending. So this is our syntax of analytical functions whenever you want to use in the query. So you have to set your function like this. And here said partition by class is a optional class, and order by class is called a mandatory. So these are the row number, rank, and dense rank. So how it was working means one small example we discuss here. Okay. Let me see first of all, I'm going to showing here. Okay. So without partition by class, okay, examples on, okay, without partition by class. I'm not using partition here. So partition by class without this, because we said this class is optional. So that's why without this, how we can write your analytical functions, how it was working here. Okay, let me check out. So come back to your database. And now, so MyDB 11a. Okay, come back to your working table. Okay, this is our working table. And on this table, what I want to do, the based on employee salaries wiser, I need to assign some rank numbers and also row numbers. Okay, now, so when we come out and see, select employee name, salary, and here first I'm using what now, row underscore number function. Okay, over class of, directly I'm passing what now, order by, on which column, salary column. Suppose a salary column I want to arrange into descending order, and that I will show as a ranks. Okay, so this is row number now, so I have show as a row number. Okay, so that is my alias name, and from EMP table. So in this case, what it was happen. Okay, so first your order by class is going to be sorting your salary column values in the descending order. So first it was going to be sorting your salary column in the descending order. after sorting of data, after sorting of data over this data, understand na? Over sorting of data. So what we want to do, row underscore number function will generating what? Row numbers, the row sequence numbers. Okay, so first executed order by clause and sorting your salaries into descending order on that data, that is called on, that means over means uske upar, yes or no? It's on the top. So over on sorting data, what it was generate, row underscore number function will be generating row sequence numbers and finally displayed. Understand na? So what I'm saying here, first executing what? Order by class. After sorting the data on the sorting data, over class is applied, over on the sorting data, row underscore number function generating numbers and displayed. Okay, na? And that I will show as a row number is alias name. That means this entire statement I'm showing as what now? Row underscore num. This is called what? Column level alias. So now I'm executing now. So after executing, let you see every employee data was arranging into which order? Which order? Descending order. Okay. Over that row number function alias name is generating your sequence numbers. Generating here sequence numbers. Okay. But in this case, I'm not using any partition by clause. So that means, can I say partition by clause is a optional? Yes or no? Yes. Without that, even though we can implement our analytical function without that. So that's why it is called as what? Optional. But without order by, you can't. Okay, na? Right. This is what row num. In the same pattern, suppose if I'm using rank function now. See row num, what I said, row num is never consider your data. So whatever the data will be sorting here, this data will never consider. But how many rows are forming after sorting? After sorting, how many rows are formed? For each row wise, your sequence row numbers are generated. But your data is not considered. Okay. Here what it will be considered? Rows are considered. How many rows are formed after sorting? After sorting your data, how many rows are forming here? On each row, your row underscore number function will generating your numbers. Okay, this is row number working nature. Okay, right. Suppose if I want to come back the same as, okay, if I want to say the rank function, let you see what it was happen. So I'm using rank. When I'm using rank function, okay, and here I'm saying that what? Not row numbers, it is a what? Ranks. So ranks is a alias name here. Okay, and now let me come and see. Suppose this query if I executed. Again in this also what it was happen, first your order by sorting your salaries in descending order, and over that data rank function will generating ranking numbers and later displayed. Okay, so displayed along with the name and the salary column. So let me see in this case. Now the ranking, sir, I was given my rank is what now? Aliases. So I was given rank, and let you see first data will be sorted. Yes or no? Sorted. Which way? Descending order, it will be sorted. After sorting this over this data, rank function will generating rankings. And see, first highest salary, first rank. Second highest salary, second rank. But what I said, for the next level of sequence order in the ranking numbers, okay, what is the miss? Third. The third rank is skipped here. So like what I said, every repetition of value, one number will be skip. The next sequence number will be skip. So your 3000, repetition of values, and assigning rank number 2. But after 2, what is the next sequence number? 3. The 3 is going to be skip. Okay. So like this, not only one time. So again, can you see here also? 1250. Again here also the data is repeated. Again repetition of data 10 is okay. But after 10, what we are expecting? 11. But 11 is there? No, here also skip. So that means how many duplicate values are repeated in your table? For every duplicate value purpose, it was a skip your next sequence rank number. Okay, so that means whatever the rankings are providing by your rank function, these rankings also not accuracy. These rankings are not a accuracy. Okay, now, so this is the problem of rank. Okay, this is the problem of rank function. So to avoid this problem, then what the people was introducing? Dense underscore rank. So now they are using what now? Dense underscore rank. So now when I'm using dense underscore rank, let me see what it was happen. Okay. Now I just executed now dense underscore rank over this sorting data ranks from EMP. Now you can see first highest salary, first rank. Second highest salary, second rank. After second what? Third rank, 2975. And fourth rank, fifth rank, sixth rank, seventh rank, eighth rank, ninth rank. So here you can see 1250, 1250, ninth rank. And ninth after 10 rank and 11, 12. So your dense rank and rank function, these are what I said. Rows are not considered. You're considering what now? Data is considered. If row considered, what is your row? Okay, 14. But here what happened? 12. Okay, now so your data is considered, not a row. Okay, so this is what now? It's what we called without a partition by clause. Okay, right. Write this 3. Both are ranking, na? Both are showing ranks. Okay, right. This is without partitions. For example, now we will see with the partitions of data. Okay, right. So in this case, observe the partition by class, how we can use it here. Observe partitions means, what is the mean by partition? It was going to be dividing some parts. Yes or no? Small pieces also we can call. So here, whatever the table data was there here, okay. So this entire the table data, we are going to be partitions here. Okay. So maybe jobs wise, maybe departments numbers wise, maybe names wise, numbers wise. You can partition this data. After partition, and every partition of data, salaries, we need to arrange either ascending or descending. And after that, we want to apply what? Your ranking numbers. Okay, this is one case. Okay, so in this, for example, let me see. So if I'm using my, okay, row function or row number function, so here observe. So in this case, I'm using what now? Partition by, okay, one of my column is, for example, DEPT number. So that means what I'm doing here, my DEPT number column data, I'm going to do what now? Partition here. Okay. And after that, on that partition of data, I'm going to apply, okay, which column? Salary column. Will arranging into which order? Descending order. Okay. So partition, after partition of your data, on each column wise salary columns wise, data will arranging into descending, and over that it was generated your sequence number and displayed. Okay, now, so now this is what it was happened. And I said here we can say row underscore numbers, it's alias name, and from EMP table. So now we can see, but here partitions how to data we don't know now. So that's why what I'm doing here, better to I'm writing here department number, which wise I did here, department number wise I did my partitions. So to understand whether it is partitions are happened or not, so what I'm doing here, so I'm adding one column. The column name is what now? Department number. So department number, row underscore number function, okay, over class, and now row num is alias, and from your table name. Okay, fine. So now you can see I'm taking this one and executed here. Okay, let me see guys here. Now the partitions are done. Yes or no? The partitions are done. Okay, so my first partition is what it is. Observe the 10. You can see that department number 10 wise, suppose first partition is done. After doing this partition, on this partition, whatever the salaries are there, which was comes under 10th partition, that salaries are arranging into descending order. After arranging descending order on that data basis, it was giving some row sequence numbers. So 1, 2, 3, 1, 2, 3. Like in the same to same 20th partition, now we can see this is my 20th partition. So 20th partition data will be sorting here in the order of what? Descending. And on the descending order, the row underscore number function will generate here sequence numbers like a 30 and 30 numbers. Okay, now this is what we called as a row num. And let me come back on this. Suppose in the partitions wise, I need to give some ranking numbers. So here partitions wise, I need to give some ranking numbers. Then how we can give it? So in place of this, what I want to use now? Rank function. So that's it. And let me come out and see. So carefully observe in the rank function. So row num place I will take as ranks, and now I just go to come back and execute it now. So in this case, you can see to execute now, again what it was happened, partitions are done here, and highest salary in 10th department, first rank, second highest salary, second rank, third highest salary, third rank, and come to 20th partition. So first highest salary, two people are there, 3,000, 3,000. then it will comes to which rank? Only first rank. But 2975 20th, we are expecting what? Second rank. But what it was there? Third rank. So that means skip now? Yes. Next 4 and 5. In the same to same 30th, first highest first rank, second highest second rank, third highest third rank, okay, and the fourth highest fourth rank. But after 4 we are expecting how much? 5, but you are showing 6. Okay, so this is rank. In the same pattern, if I want to go for, okay, so what I am using here, dense rank function. So I'm using here dense rank. Okay, now right. Let me come out and see. So come to in dense rank. Come to your dense rank. Observe. So now in dense rank I executed now. In dense rank carefully observed. Same as. So department number 10. So sorting and ranking numbers. Department number 20. Sorting and ranking. But yet see the 3000 3000 it was showing as a first rank. And what is your rank function now? Okay, right. So now we can see dense rank. We apply dense rank here. Okay. So first partition, the ranking numbers, and second partition you can see. So 3000, 3000, rank number 1, and 2975, rank number 2. So there is no skip here. In the same to same 30th, okay, department. So first highest first rank, second highest second rank, third highest third rank, and fourth highest fourth rank. And next one is what? Fifth highest 5. Okay, so your accurate rankings are showing us. Okay, now? Right. So now take this. Okay, right. So by using of this analytical functions, okay, let me see how I want to use these functions in my queries. Okay, let me see some query examples. First example, write down. Write a query to display third highest salary employee from each department number wise, from each department number wise by using dense underscore rank function. So why I'm taking dense underscore rank function? Because it was giving accurate rankings. That's why I'm not taking any rank function, okay, or row number. So I want to take with the dense rank. So dense underscore rank function, okay, along with inline view subquery statement, along with inline view subquery. Okay, right. Now the question understand. So what I need to find out here, third highest salary employees from each department number wise. Okay, now? So how we can find out means by using of a dense underscore rank along with the inline view statement. Okay, let me come out and see guys here. For example, this is my, okay, the query we written by using of what? Dense rank function and partition by on which column, department number and sorting. So already this query when we executed, this query written some result. And what I said here, this query, whatever the return, it was, whatever the result was written here, this result will be act as a table for outer query. Yes or no my point? Now we can see. So now, then I will write a inline view. Select star from off. So now we can see already by the help of this inline view, by the help of this query, for each department number wise, your data already partition. And after partition, their salary is also arranging into descending. And after ranks also allocated. So now we can see, I wanted what now from each department number, third highest person find out. Now department number 10. Who is the third highest? Miller. His rank number how much? 3. His rank number 3. Next in 20th department, I want to find a third highest salary. So this person, who is this person here? Yes, Adams. So third highest person. In 30th department, who is this here? Turner. Turner is the third highest salary person. Okay. So that means already by the help of this query, already the data will be sorted. And sorted, partition, after partition sorting, and after sorting we are applied ranks also. So based on this ranks, I want to find out third highest salary. Now tell me, now here ranks is called as this is what I said, this is a alias name for your inner query, whatever the query. So this is alias for inner, but this is column for outer. Yesterday we discussed inline view, recall. Okay. So now I can say, let me come out and see, can I copy this entire query? Yes or no? Yes, I can copy this. And I just close this up to here. This is called the inline view is happening. inline view is happening. Okay. And now after what I want to use, select a star from EMP is over, where what is that? Ranks. Ranks are ranks. Ranks is equals to which rank? Suppose if I given 1, what's happened? From each department number, that means from each department, first rank, that means first highest salary employee display. If I given 2 means second highest. If I'm giving 10 means 10 highest. If I'm giving 100 means 100th highest. Yes or no? So that's your wish. So now I want it what now? Third highest. So rank is equals to 3. And wherever this ranks column satisfied, there it was going to be ranks. It was working with year matching. 3 is equals to 3. Condition true. Next year 3 is equals to 3. Condition true. Next year 3 is equals to 3. Condition true. Yes or no? So now I'm just go to execute here. Okay, fine. To execute now and see your each department number wise third highest salary employees we find out. Got it? This is very important for your interview questions. Okay, na? Right. So now write down this example. So subqueries are very important for your interviews, guys. Okay, na? So more focus on subqueries. Okay. The same way, one more example I will give it. Can you try it? Try this. Write a query to display fourth senior most employee from each job wise by using dense underscore rank along with inline view. Dense underscore rank along with inline view. Now here observe. Now which at the senior employee wanted? Fourth senior employee from each job. Okay. Fourth senior. So which wise I'm finding? Job wise. Now tell me. That means my partition key I want to apply on which column? Job column. So partition I'm applying on job column, and order by I want to apply on higher date column. Higher date. You're not salary. I'm asking what? Senior most employee. I'm not asking highest salary here. I'm asking what? Senior most employee. Senior most employee, how to find out? Based on their date of join. Okay. So this is your table. Table also I'm showing. Once check out table. Check out your table once. So jobs are there and higher dates are there. Now what I want to do, for example, here observe, clerk is there. In clerk, how many people just find out? 1, 2, 3, 4. The 4 people working in a clerk job. So one employee joined in 17 December 1980s. One employee joined into 12 January 83. One employee 3rd December 81. And one employee 23 January 82. So I wanted who? 4th senior. 4th senior employee is there in this clerk job. You have a 4th senior. Who is the 4th senior will come? Miller. Miller, huh? Sir, Miller not. No. Miller not. Adams. Adams is the 4th senior most employee because Smith is joined in 1980s. He is not a 4th senior. Yes or no? Next, Adams was joined 83. James was joined 81. And Miller joined 82. So that means who is the 4th senior? 83. Okay. So, okay, sir, the clerk people are having 4. The 4 people, 4th senior, I find out. But when you come to managers, can you see managers? How many managers are there? Only 3 managers are there. So that means in the manager job, do you have any 4th senior? No. So that means data returns or no return? No return from manager. So, and like analyst is there. Analyst, how many people are there? Only 2 people. So do you have any 4th senior? No. So no data. Next, president. No, only 1 president. Next, salesman. 1, 2, 3, 4. In salesmen also, there 4th senior. So that means in which jobs are there? Clerk and salesman. Remaining jobs, there is no 4th senior most employee. Now let you write. How to write now? First inner query. First inner query write down. What is inner query? Select e-name, comma. What I want to take? Hire date. Your salary is not necessary. Only hire date. And which column next? Job. After that, which key? Dense underscore rank function over class of partition by. On which column partition? Job column. Very good. Job. And next one is what? Order by. On which column? Hire date. Now see. Order by column, I want to arrange in a ascending order or descending order. Because I want it what? Seniors. Seniors means ascending or descending? Ascending. Yes or no? If you arrange ascending order, then we can find out seniors. If you arrange a descending order, then we find out juniors. Okay, so ascending. Ascending means by default, no? Yes or no? Yes, I don't want to give any key here. Okay, fine. And after what I say, these are called as a ranks. Okay. From which table? EMP table. This is first inner query. So first inner query, let me see first of all. So first analyst is separated one group, one partition here. Okay. So this is analyst job is a partition. In this, how many people? Only 2. Those people, okay, the way of hiring dates are which order? Ascending order. Ascending means what now? Small to bigger. Ascending means what now? Small to big. 81, 82. And ranks are 1, 2. Next we have your clerk. The clerk partition. They're ascending. And here have a 4th senior. Yes. In clerk job, you have a 4th senior. So he was joined in 1983. His name is what? Adams. And the next come to your next managers are there. But in the managers, there is no 4th senior. Next what now? Salesman. In salesman, you have a 4th senior now? Yes. So that means 4th senior is available. In which jobs? Clerk job and salesman job. Okay. This is inner query. Okay, fine. Then what I want to write? Outer query. Outer query, how to write? Select. Select star from of. Can I say this entire query? Can I copy this? Yes, I can. So I'm just copy this one and copy paste. Okay. After that, what I'm writing? Ranks. Okay. And from which table? EMP close. Okay. Ranks from EMP close. And what is your condition? Where ranks is equals to, which is senior you wanted? Fourth senior. So rank is equals to 4. And condition is this. And this fourth rank is equals to 4 condition is going to be checking. Now tell me, 1 is equals to 4. Condition true or false? False. 2 equals to 4. False. 1 equals to 4. False. 2 equals to 4. False. 3 equals to 4. False. 4 equals to 4. Yes, true. Next, 1 equals to 4. False. 2 equals to 4. False. 3 equals to 4. False. 1 equals to 4. 1 equals to 4. 2 equals to 4. 3 equals to 4. And 4 equals to true. This is what where condition is checking. I already said now, where condition how it is checking? Each and every row value check. Okay, fine. So now after that, let you come back and to execute this one. Okay, fine. And who is the senior most in clerk and salesman? So Adams, Martin, these are the fourth senior most employees. That means there is no fourth senior most employee in a manager job, in a analyst job, in a president job. Okay, now write down this. Okay, right. So this is what now the dense rank analytical functions, how to use in our queries. Okay, now, so these are complete your non-correlated subqueries. Okay, na? Single, multiple column and inline views. Okay, na? Right. But here in this non-correlated, okay, one of our problem is we discussed. Can you remember this problem? Yes or no? Nth means n plus 1 times we are writing to finding nth highest salary or lowest salary. We need to find out n plus 1 times. So there we said how to overcome this problem. Okay. So we said in the last class, that means before starting classes. Okay, now, so this problem, okay, I can overcome by using of your, what it is the next, what is the next category of, okay, what is that? Correlated subqueries. Okay. So by using of correlated subquery, how I can avoid this problem, which was finding that nth to n plus 1 times. Okay. Right. Let me take siding correlated. So correlated subqueries, the first what we said, the definition. In this correlated subquery first, what was executed first? Inner query or outer query? Outer query. Okay, so in correlated what we said, the first outer query executed, return some values based on written value of outer query, later inner query execute and produce your final result. Okay now? So now by using of this correlated, how I can find out nth highest and lowest observed. So first syntax I do. Syntax to find out nth highest or lowest salary. Okay, the syntax careful observe. So maybe a little bit confusion, but try to understand. So select star from table name, table alias name 1. Okay, table alias name 1. Next, where n minus 1 is equals to of inner query select count of distinct keyword, distinct column name of, so from table name and table alias name 2. Okay, so where table alias name 2 dot, okay, column name either here I'm using either less than or greater than, then I have to use table alias name 1 dot column name, okay, and close. So very simple, Corina. Completed. Now the syntax observed. Okay, so what is my syntax here? Select a star from table. Here only one table, guys. It's not a two table mechanism. It's only one table. But on the table, what we want to create? Aliases. And we know so already in self join. Did you remember self join? That explanation, remember na diagram explanation? So same as correlated also. Same as correlated. So here on the table, I'm creating one aliases. Then what happened? I said one virtual table is created by your Oracle internally. So now this is my condition. What is the condition? N minus 1. But non-correlated condition is what now? Non-correlated condition is what now? N plus 1. So non-correlated mechanism through, we are using what now? N plus 1 formula. So based on N plus 1 mechanism, we are finding your highest salaries. Okay. But now here correlated mechanism is what now? Correlated mechanism is what now? N minus 1. First difference observed. That is N plus 1. This is N minus 1. Okay. Of N minus 1 is equals to inner query. Select count. So count function you already know now? Yes. And here distinct. Why sir we are using distinct here? Already I discussed in early classes, starting classes, introduction. Distinct means duplicates are count or avoided. Avoided. So duplicates will never counting here. It's a avoiding. So avoiding of your duplicates from so and so column. That means in which column do you have your duplicate values? Those values are avoided here. Okay, not counting. So that is what distinct keyword I'm using. Right? Now, from table, exactly on the same table, again, second alias name I need to create. I want to create a second alias name. And whereas now table alias name 2 dot column name, here I was given less than or greater than. So what is less than, what is greater than, sir? So here less than we are using to finding nth lowest salary. Less than purpose is what? Lowest salary. Because how we say first highest, second highest, third highest, same pattern, first lowest, second lowest, third lowest salaries I want to find out. So in that case, I'm using what now? Less than. And whatever you are using is greater than to use it for highest salaries. So whenever you want to find out highest salaries, use greater than. Do you want to find out lowest salaries? Use less than. Okay. Then table alias name 1 dot column name. Okay, now this is what syntax. And here, what I'm saying here, less than when I want to use, I said, for low salary purpose. For low salary. Greater than for high salaries. For high salary. Okay, now these are the symbols we are using, guys. Fine. Let me see. Sir, how this syntax will be work? Okay, we will see some practical examples on this. Okay, now, right. So first of all, come to my database, guys. Here, I'm creating one sample table. Okay, let you come on and see. I'm creating one sample table number test, suppose EID and E-name, for example, and now salary. Okay, later I'm inserting few records into this table. Okay, so I'm percentage of EID, I'm percentage of E-name, I'm percentage of salary. Test sending value, I am percentage of EID, I am percentage of E-name, I am percentage of salary. So EID 1021. Name is Alan. Salary 85,000. Okay. Next 1022. The name is James. Salary 60, otherwise 28,000. Okay. Next 1023. The name is Ward. Salary 45,700. Next 1024. Okay. The name is Smith, and salary was okay 61,000. Next 1025. The name is Miller. Salary 85,000. Next 1026. The name is Scott. Salary was 33,000. So now I just made it commit. Okay. The first time showing one small table I'm taking, guys, because comparison purpose, it was easy for us. Okay. Right. So I'm taking one small table. In this table, total how many employees data we have? 6 employees data. We have it here. Okay. Now fine. So in this, some employee 85, 28, 47, 61, 85, 33. But can you see this in this? There are 2 employees are having their salaries are same. Who is this? Allen and Miller. So that means there is a chances in a company, there is a chances the both employees are having same salary. So in that pattern, I will take in. Okay, fine. This is one small table. So from this table, I need to find out my first highest salary employees. Okay. So then what is my question here? Write a query to find out the first highest salary employee details. Okay, no? Right. So I want to find out the first highest salary employee details. Okay. Now, so details. So by using of what now? Correlated subquery. Now let me see. So this is my syntax. Carefully observe. Okay. The first of all, as per the syntax, I'm writing now my solution. Careful observe. Above syntax is there. I'm below writing. Select star from table name. What is our table name? Test. What I want to create? Alias name T1. So T1 where? Okay. So already I finished here. Up to here, finished here. Where? Here n minus 1. What it was there? N minus 1. So this n minus 1, how we can find out? Means here n minus 1, how to find out means very simple. To finding, okay, how it was means n minus 1. Okay. Here observe. Which highest do you want to find out? First highest. So my requirement is to finding the first highest. So finding the first highest means, can I say my n value? Here I said nth. Nth means n value. Okay. So n value, how to decide which highest are you finding? That is your n value. Understand my point? Suppose here, which highest I'm finding here? First highest. So that means here n is equals to how much? 1. Understand na? Suppose my question is, if I'm asking 10th highest, then n equals to how much? 10. Then if I'm asking, I want to do 100th highest, then my n value, how much? 100. If I'm asking 1000th highest salary, then n is equals to how much? 1000. So like this. So which highest do you want to find out? That is your n value. Clear na? No doubt about na? Yes or no? So now okay. Now we are finding which highest? First highest. So n is equals to how much now? N. N is equals to 1. So this n value, I need to substitute. Which formula? n minus 1 formula, mathematics, substitution. Okay, so n minus 1 formula. Now pass it. What is n value? 1. 1 minus 1. So 1 minus 1 is equals to how much? 0. Okay, now? Now tell me. Finally, n minus 1 is how much? 0. Understand na? So that 0 I'm going to keeping here, where 0 is equals to of your inner query. Inner query is what? Write down. What is inner query? Select count of, which keyword I'm using? Distinct. But distinct keyword, why I'm using, sir? If you have a doubt. So using what purpose? To eliminating of your duplicate countings. Okay, countings I'm telling. I'm not telling duplicates. Duplicate countings. Okay. So distinct. On which column? Salary. This is over. Then from which table? Same table tester. And what next? I have to create another alias. What is another name? T2. So T2. Where? Now what I said? Where I said inner query. Inner query is what? Where? Here we came. Table alias name 2 dot column name. Okay, fine. Table 2. Table alias name 2. 2 means what? T2 dot column. Which column? Sal. Here, okay. Here what it was there? Less than or greater than. But what I said? Highest. Highest means what I want to use? Greater than. Okay, fine. Let me come. So greater than. Next what now? Table alias name 1 dot column. So now we can see table alias name 1 dot column. Yes, I just close and terminate. Syntax now understand na? Formula. Understand all of you? Same the formula I am using here. So as it is query, whatever we written, the same query, let me find out to execute here and see your query is executed and first highest salary employees. How many people are there? 2 people. The 2 people information we got. Okay, now? Right. So this is what? So like this, for example, if I want to ask you, okay, if I want to ask you, my second highest if I'm asking, suppose, here I will take out, okay. So if I'm asking, second highest if I'm asking, then n equals to 2. N minus 1, 2 minus 1. 2 minus 1 is equals to 1. Where I want to substitute? Here. That's it. So I don't want to add multiple queries. Just a single subquery. Single. Here only single subquery, na? Only single subquery I'm using in this. So with the single subquery statement, we are finding which highest? Second highest. But the same second highest, whenever you want to find out in non-correlated, how many? 3 are? 2 plus 1. 3. Okay, na? But here n minus 1. That means 2 minus 1. Here what? 1. Okay, let me see. I'm executing this one. My second highest salary employees are getting or not. Find out. Okay, yes. Second highest salary, how much here? 61,000. Now if I'm asking now, for example, I wanted fourth highest. Then n equals how much? 4. N minus how much? 3. For n minus 1 is equals to 3. And where I want to substitute? In n minus 1 place. 3. That's it. And remaining query is same as it is. Now I just copy this and execute here. Okay. And see and execute my, what is the fourth? Fourth highest is 33,000. We got it. Okay. Now tell me, with a single statement, we are finding any nth position. For example, your interview person is asking 30th highest salary. Where I want to change? How much I want to give? Come on. 30. 30 minus 1. 29. So 29 you just apply here. That's it. You will get a 30th highest salary. Suppose 150th highest salary I want to find out. Yes, simple. 149. That's it. You don't want to write any query. You don't want to add any query. Just n minus 1 value change. Suppose I'm asking 1024 highest salary. 1023. That's over. 2005. 2004. Like you have to find out nth. Nth means any position. 1,000, lakhs, crores, millions positions you can find out. But here how many subqueries I'm using? Only single subquery. I'm not using hundreds of queries. I'm not writing here. But same 2004, if I use in my non-correlated, how many queries you need to write? 2005 queries you need to write. There are how many years gone? 2005 queries you need to write. How many days will take to write that query? 1 month, 2 months, 3 months? 2 months? Ramakoti. Write down. Lakhs of. Yes or no? So that is what. So now, here what happened here? So 2004, 2005. Okay. So, but here not necessary in the correlated. Okay. So just n minus 1 formula will be changed. Now what is my question? First I asked. So n equals to 1 and 1 minus 1 is equals to 0. Okay. And that 0 I'm applying here. Okay. 0. That's it. Okay now. First write down this one. First the solution, take it. I will explain later. Non-correlated. Because that is least values now. So when they will ask you the biggest values like 30, 40, 50, then you can prefer correlated. The starting 1 means you can use 1 also. This also you can use, no problem. Okay now? Right. So this is what we called correlated. But the question is, sir, output came, that's okay, but how this query internally executed? Yes or no? So that we are waiting for that. So whatever it may be, but output is came. But how this query will be executing internal process. Internally how this query executed and how this condition will be verified here. Okay. So that we will discuss in tomorrow's session. Okay. So that mechanism will take much time. Okay. So tomorrow I will postpone that and we will see that. Okay. And one more thing. If anybody wanted Naresh IT ID cards, okay, they are providing ID cards in the ground floor. Ground floor means first floor, this is second floor, third floor. Oh, they decide like that. Okay. Don't go cellar. Okay. Cellar is different here. Don't go cellar. Ground floor, but they are calling first floor. Okay, whatever it is. You understand, na? First niche, sabse niche. Sabse niche means don't go jamin ke andar. It's a ground floor or first floor, whatever it is. You just go and collect your ID cards. Okay, na? There it was giving. Go and take. Go. पास हो गए 16 पास हो गए सो 16 से 17 छोड़ दो 18 से स्टार्ट कीजिए जैसे 18 जून जून से स्टार्ट कीजिए 18 जून से 19 जून क्योंकि अब 16 को 16 पास हो 17 छोड़ दो क्योंकि आप ऐसे बोल सकते हैं कि मैं एक साल का थोड़ा कोर्स कंप्लीट करना है पूरा हो गया मेरे को so ऐसे 1 year I was आपका लेना पड़ेगा वही करेक्ट है वो बता दो जैसे आप पूछेगा so why you taken this gap okay then you have to tell them ये ऐसे हो गया तो वो कुछ नहीं आपको कंसीडर करेगा वो तो आप कहाँ से करेंगे 17 से करो 17 जून से करो 17 जून में मेरे को ऑफर आया एंड मैंने ज्वाइन किया 17 जून सो 17 जून से 18 जून एक साल होगा 19 2 साल होगा 19 से 20 3 साल होगा 21 4 साल हो जाएगा सो क्या करेगा आप 2018 से पढ़ेगा तो 3 साल आएगा 18 जून 19 जून 20 जून 21 ये रखो और ये 2 साल का गैप आपको रीजन बता दो मतलब ऐसे हुआ सर मैं ऐसे पढ़ता था ऐसे पढ़ता ऐसे ऐसे करेंगे तो आपको 3 प्लस और कितना आएगा तो 3.1 और 3.2 एक्सपीरियंस आएगा और 3.2 में आप एक्सपीरियंस आएगा सर करेंसी आप 2021 का डेटाबेस का आप जा रहे हैं तो ओनली वैरायटी आप ऐसा रख सकते हैं कि 6 to 7 expected मैं तो 6 रखो expected 8 लगाओ expectation 8 प्लस का so 8 एक्सपेक्ट करो और आप 8 एक्सपेक्ट करेंगे तो वो आपको 7 में आ जाएगा और 9 एक्सपेक्ट करेंगे तो 8 में आ जाएगा ऐसे थोड़ा ज़्यादा बोला जाए so आप 8 at the time of when I'm working I take 6 lakhs package so now I'm expecting 8 or 7.5 8 and a half so they will come to 7 let's expect that sir basically admin level knowledge आपको but Linux आपको चाहिए Linux वो course आपको because as a database programmer when you're working in real time mostly those people are using Linux operating system so उसके बारे में थोड़ा आपको आइडिया रहना चाहिए because आप 3 प्लस रखता है तो उसका नॉलेज रहना चाहिए यहाँ पर आप एडिशन में लेते हैं 45 days वो Linux में लेना है तो ले लो यहाँ पर Linux में वो भी नहीं तो आपको ये काम कर सकते हैं एक बार गूगल से प्रैक्टिस करो गूगल पे देखो Linux का वीडियो से रहता है वो देखो वो आपको समझ में आ रहा है तो आप ऐसा प्रिपेयर कर सकते हैं नहीं तो आपको ट्रेनिंग लेना पड़ेगा अभी आपके साथ नहीं बैठ जाएगा नहीं उसको अभी फैमिली में कोई नहीं ना सर फैमिली में पापा तो बड़ी दिन की मैरिज हो गई ना तो उसको मैं बोली मुझे कोर्स करके आना है तो मैं आपको थोड़े अच्छा आप कहाँ थे सो अभी घर में भाई है तो आप यहाँ वही ऐसा ट्राई कर सकते हैं Linux को